Here is the theorem for changing of variables for definite integrals. If we have a function u that is equal g of x, okay, it has continuous derivative on closed interval a, b. So derivative is continuous, doesn't have any break, interruption on the closed interval a, b. And f is a continuous on the range of g, which means going to be f g of x. Function f is continuous on the range of g. Then we can say that integral from a to b f of g of x times derivative of g of x dx is equal integral g of a lower limit boundary and upper boundary is g of b, and f of u du. Let me move it in the center. Okay, so let's start practicing this, solve a couple of this theorem, solve a couple of problems and see how it's gonna work out. Change of variables. All right, question number 1. We have integral from 0 to 1 x times x squared plus 1 cubed dx. Okay, to evaluate this integral, we are going to take u as x squared plus 1. Then we are going to obtain du, which is gonna be 2x dx. Yes? Okay, so before we substitute it, we need to determine, because substitution brings changing the boundaries, upper boundary and low boundary, right? So we have our boundary right now from 0 to 1, which means when x is equal 0 for low boundary, right? Low boundary, when x is equal 0, then u is equal 0 squared plus 1 is equal 1. Upper boundary is going to be x is equal 1 and u is equal 1 squared plus 1 is equal 2. Okay, now as we substitute the x with u, we will replace also the limits, low limit, upper limit, or low boundary, upper boundary. And this is what we are getting. Integral from 0 to 1 x times x squared plus 1 cubed dx is equal. So from 0 to 1, we have, we need to get 2x, right? Because du is equal to 2x. So to get here x squared plus 1 cubed, and I will here squeeze multiplication of 2 with x dx, and at the same time I will divide here by 2, right? And from here now I'm going to, since I'm doing transfer to u, I'm going to replace this limit also. So it's going to be equal limits. It's going to go Now from 1 to 2, here it is. U is 1, U is 2, because X is 0, here it is. U is equal 1, we replaced, and X is equal 1, U is 2, here it is, we replaced. Okay? And we are going to get U squared. I'm changing color, so you will see those are new changes. U cubed, I'm sorry. U cubed du. And that is equal 1/2. Also, let me add here this 1/2. All right. So this is equal 1/2 u to power 4 divided by 4, right? And limits 2 and 1. Now it's going to be equal 1/2 2 to power 4 over 4 minus 1 to power 4 over 4. All right, and we are getting 1/2. 2 to power 4 is 16. 16 by 4 is 4 minus 1/4. Yes, and the result is going to be 1/2 times, it's going to be 3 and 3/4. Okay, let's do multiplication. 1/2 times 4 is going to stay here. 3 times 4 is 12. 12 plus 3 is 15. And result is 15 over. Next problem. So evaluating the definite integral by changing variable. So we have integral from 1 to 5 x over square root to x minus 1. Okay, and dx. All right, to evaluate this integral, let's take u is equal square root to x minus 1. So from here, if I want to find x, so I need to square both sides. Remember how we solve equation with radical? So we need to raise, okay, to power whatever degree of radical is. Since we have 2, that means we are squaring. So it's going to be u squared is equal to x minus 1. So from here, u squared plus 1 is equal to x, and dividing by 2, we are getting u squared plus 1 divided by 2 is equal x. And we need also to find out du by dx, right? So let me write down u squared plus 1 over 2. It's u squared over 2 plus 1/2 equal x, and then we need also to get derivative, right? So we are taking derivative on both sides. So dx by du is equal 1/2 times 2u, and plus here would be 0, obviously. Okay, this 2 here and here is gone, and we are getting dx by du is equal u, and from here dx is equal u du. Okay, so now let's go to identifying the limits for u. So low boundary, how much we have here? 1 and 5, right? This 1 and 5. Okay, so for low boundary, when x is equal 1, then u is equal square root. We are using this one, see? Let me clean and go over it one more time. Here it is. 2x minus 1, right? U is equal to x minus 1, which is going to be equal 2 times 1 minus 1. That is going to be equal 1. Okay. And the upper limit or upper boundary is 5, right? From this integral I already told you, showed you. 1 x is equal 5, and u will be equal accordingly 2 times 5 minus 1, it's going to be 3. So let me now write out everything we did and what we're going to replace here. So we need to have replace x and square root 2x minus 1, right, and dx. So our component is going to be x is equal u squared plus 1 over 2, right? Let me clean this here. Okay. Next, square root 2x minus 1. It's going to be replaced by u. Yes. Okay. What else do we have? We have low boundary, upper boundary. Low boundary is going to be 1. Upper boundary is going to be 3. And we have dx. Okay. And we have u du is equal dx. Hold on. Dx is equal u du. Okay, so we have everything we need. Let's plug in now. So it's going to be integral from 1 to 3. We have x is going to be u squared plus 1 over 2. Square root 2x minus 1. It's going to be u, 1 over u, right? Because we have 1 over square root 2x minus 1. And dx is going to be u du. Okay. So from here, we are going to have integral taking constant out, and we are going to have upper boundary, lower boundary, upper boundary, u squared plus 1 du. Because we have here canceling, right? This u's. Okay, so, and this is going to be equal 1/2 u cubed over 3, 1 and 3, and plus u, 1 and 3. So from here, we are going to get 1/2, and that is going to be equal 3 cubed over 3 minus 1 cubed over 3, and then plus, now let's replace u. It's going to be 3 minus 1. And this way we are getting 1/2. So 3 cubed is 27 by 3. It's going to be 9 minus 1/3 and plus 2, right? And from here we get 1/2, and 11, 9 plus 2 is 11. 11 minus 1/3, it's going to be 10 and 2/3, which will have 1/2. 33, 10 times 3, 30, and plus 2, 32 times 32. Here is 3. This is gone. Here is going to be 16. And the answer is 16 over 3. So geometrically, we are going, we can interpret the equation the following way. This is the answer, obviously. Let me write down 16 over 3. Okay, let's do geometrical interpretation to this. Between 1 and 5, x over square root 2x minus 1 dx is equal 1 and 3 u squared plus 1 over 2 du, right? This the change of variable we did. So if I graph these two integrals, so let's say this one for x, the integral with x, let's say, okay, let me graph here so we can see which one for which one. Okay, so if this point is 1 and 1, and this is too much, the slope has to be less. Okay, and this point is 5 and 5 over 3. Obviously, I'm not looking and just drawing like that. It's just I already prepared, so I know the point. 5 over 3. Here is, let me write down this way, 1 and 1. So the area under this graph is this, right? Because integral is dealing with areas, right? Okay. All right. And this is x and y. And the other one with u is going to be the following. And that is going to be u and f of u. So one point is 1 and 1. Okay, 1 and 1. And I'm going to do approximately, so please don't judge me for proportionality of these points, but approximately it's gonna look like this. A little bit 1, 2, 3, maybe even higher slope, like this. Yeah, this looks, and this is gonna be 3 and 5. All right, and the shaded area underneath, it's gonna be this. Okay. So what does that mean? That areas under these two graphs are equal, it's the same. Okay? All right. So the something I wanted to note, when you are evaluating definite integral by substitution or replacing variables, it is possible for upper limit of integration of the u variable to be, okay, let me explain. Let's say we have here with 1 and 5 f of x dx, and we substitute it. When we substitute, we get, for example, 1 and 0. Here is some negative sign, for example, and we get f of u du. Okay? We replaced with fu du, and as you can see, upper and lower limits, practically higher limit fell as a low and limit, and the smaller number became as a higher limit. And in this case, you don't need to switch them. Take them the way it is and work with these boundaries. There is no need, because why? Because this is gonna be temporary, right? You are going to go back. The true limit is this one, 1 and 5. So although we have here 1 and 0, but realistically it's 1 and 5, correct? U du is simply temporary substitution. Okay? All right. And as always, thank you very much for watching. And I'll see you in next video again.